So question 2, part C. So we have been given lots and lots of electrode potentials here. We've been given everything for iron, everything for chromium, and everything to do with the water and the acid below. So remember, all you're ever trying to do is identify a pair, one of which goes forwards, one of which goes backwards. We've got to identify the species in this question, and we have to write overall equations for each reaction that takes place. We don't need state symbols, so let's have a read of what we've got here. So the student adds iron filings to dilute hydrochloric acid. That means we've got iron solid going in, and we've got hydrochloric acid, so we've got H pluses and we've got Cl minuses going in here. You get a green solution that should make you think of Fe2 plus, and you've got gas bubbles. So your only possibles for your gases are these structures. So although I'm highlighting here, anything to do with your answers should not be highlighted, and that's just me going through this paper. You're okay highlighting up here because it's part of the question, but you shouldn't highlight any text that you've actually written down on here. So taking this through then, so if the that says that if we're taking a look at this, then we've got iron beginning with it. We've either got H plus or Cl minus reacting with it. So let's go back up to these. So we are looking at, we're looking for iron anywhere in any of these. So that's the only one there that's got iron in it. And iron is going to need to go backwards. So you need something that is more positive. So that's any of the other ones here. And you need to have either H plus or Cl minus on this side to make that one happen. So the only one of those two that is on that side is here. So we have this one going forwards and we have that one going backwards. So when you pop those two together, on the screen, when we pop those two together, then we've got the Fe and the 2H plus going in the forwards directions, and they're going to produce the H2 and the Fe2 plus going in the reverse direction. And we've got the right number of electrons for both of those. Yeah, when we look up here, we don't have to do any times in by anything because both those have got 2 electrons in their process. So that means that our green solution was Fe2 plus and our gas is H2. Keeping those just on screen then. For number 2, the student bubbles air through the green solution, so they're going to bubble it through our Fe2 plus, and it's we're going to get an orange brown colour. So orange brown should make you think of Fe3 plus. So knowing your colours of your aqueous ions is really, really important in these types of questions. And if they say air, then we're talking oxygen. Yeah, nitrogen's not going to react here, so oxygen here. So we are looking for something that starts with our Fe2 plus. So we've got a couple of choices for Fe2 plus, and we know that we're going to go to Fe3 plus, so we're looking at this one this time. So Fe2 plus to Fe3 plus. If that's going backwards, we want something that's going more forwards to make that happen. And here we are, here's our oxygen, more positive than that one was. So oxygen can come forwards, that one can go backwards, this one's going to have to be times by 4 as it goes in, so you're going to have all of those happening but 4 of both of those. So there we are, 4 Fe2 plus, the O2, 4H plus, and 4 of these, and 2H2O, and the orange brown belonging to that. So in the second part of the question, experiment 2, we have got green chromium. Yeah, so this is our chromium 3 plus solution, which is green, and hydrogen peroxide, and it turns an orange colour. So we should be clued into from organic and all over the place that this orange is Cr2O72 minus. So that should be a pair that we're remembering. And then the equations that we will be using, if we go back up to the top, we've got the chromium one there, which needs to go backwards, and it will be driven by this one over here going forwards with the H2O2 in it. So you can find a space maybe to write these out. So you've got that one, and you've got this one, and this one's going forwards and that one's going backwards. But what we need to spot first of all is we're going to have to do a ×3 on this one. So we can add all of these together, and then we can combine them and we can cancel out. And you can see when it's laid out like this, you'll be able to cancel the waters down to 1 because you've got 6 and 7. Those cancel, and these will cancel out over here. From 14 take away 6 will give you 8. So when you've put it all together, this is what you get. Remember, you cancel H pluses, you cancel waters, you cancel electrons.